Welcome to our presentation. In this talk, we will discuss electrodermal activity as a biometric method for studying listening anxiety. My name is YOU&Suvorov, and my co-presenter is Guy Yu from the University of Western Ontario in Canada. In this talk, we will provide a brief overview of anxiety. We will discuss methods for investigating listening anxiety specifically, focusing on electrodermal activity, and we will provide a brief overview of an EDA study on L2 listening anxiety. Before we start our presentation, I would also like to acknowledge that the study was supported by the Social Sciences and Humanities Research Council Explore grant from the University of Western Ontario. So what is anxiety? Anxiety is an emotional response to an anticipated threat. Anxiety has a lot of negative things. It reduces attention and processing. It can impair test performance of students. However, anxiety is not always a negative thing. A moderate level of anxiety, a moderate level of physiological arousal can actually help students with performance, whereas too much arousal hinders their performance, and that's according to the Yerkes-Dodson law. In language learning, there is a concept of foreign language anxiety. This was introduced by Horowitz and colleagues in 1986. The symptoms of foreign language anxiety include freezing or blanking, and foreign language anxiety is oftentimes linked to lower achievement and is considered to be particularly disruptive in speaking and listening assessments. There are different methods for studying listening anxiety. We will discuss three main methods. The first one is survey methods. This is a most common group of methods in research in listening anxiety. And survey methods typically utilize interviews or questionnaires to elicit students' perceptions about their anxiety level. And one of the commonly used listening anxiety scales is foreign language listening anxiety scale. There are limitations of survey methods. They rely on self-reported data. They are prone to recall bias and oversimplification. So oftentimes what the students report feeling about anxiety does not necessarily reflect how they felt. And survey methods provide only a static measurement of anxiety, which is a dynamic construct. So anxiety is not the same throughout the whole, let's say, listening test. It changes dynamically during the test. So to address the fact that survey methods capture only this static picture of anxiety, some researchers started using an ideodynamic method. The idea behind the ideodynamic method is that it records moment-by-moment self-rating of anxiety during the task video replay. So the basic idea here is that the student's performance on a listening task is video recorded, and then it is played back to the students, and they're asked to rate how they think they felt in terms of anxiety, let's say every 10 or 20 seconds. This method has high temporal precision. It captures intra-individual variation, but similar to survey methods, it relies on self-report data. It can also introduce a recall bias in ratings, and it captures perceived anxiety, how students, how they think they felt, rather than the underlying physiological arousal. So to measure the actual physiological arousal, which is part of the anxiety, some researchers started using biometric methods. And biometric methods utilize physiological measures such as heart rate or heart rate variability, as well as electrodermal activity. And electrodermal activity is what we will focus on in our presentation. So these methods provide more direct, continuous, and objective insight into emotional arousal, and they measure EDA, specifically electrodermal activity, measures skin conductivity changes via sweat gland activity, which is not voluntary and is not subject to conscious regulation. So if we were to summarize these three methods, we can say that survey is an easy and scalable method to use, but one of the limitations that it is based on self-reported data. It is prone to recall bias, and it captures only a static measurement of anxiety. Ideodynamic method, unlike survey method, can capture dynamic changes in anxiety, but it is still prone to recall bias as it is based on self-report data. Biometric methods are good because they can capture real-time physiological data, but they require specialized equipment, which is not always possible to have around. And another important limitation of biometric methods is that they measure what we call physiological arousal, which can indicate not just anxiety per se, but also other related conditions such as stress or excitement. So on this slide, we just show a brief overview of how electrodermal activity works. So when there is an emotional or cognitive arousal that transfers to the sympathetic nervous system activation, it activates eccrine sweat glands, and that leads to changes in skin conductance, which is captured by EDA sensors. So before we start talking about the actual sample study, we would like to also say that an EDA signal comprises two primary components. These are skin conductance level, or SCL, which represents the tonic baseline reflecting general arousal. So that would be this green line on the graph, whereas a skin conductance response, or SCR, refers to the phasic burst associated with specific stimuli. So, for example, if a student hears a difficult question during a listening test, then that can lead to an SCR event which reflects increased emotional arousal or potentially anxiety. So now Gayul will talk about a sample study in which we will demonstrate how we applied EDA to study anxiety in a listening assessment context.
Next, I will present one of the research questions from the study since it's a quite big research. The research question is, to what extent does music affect test takers' emotional arousal during an L2 listening test? This study employed a quasi-experimental within-group design. Here, the dependent variables are test scores and 3 measures of emotional arousal, and the independent variable is relaxing music. There are 38 L2 English-speaking graduate students at Western University aged between 22 to 44 participated in this study. And the majority were reported as intermediate to advanced English users, and most reported Chinese as their dominant language. For the listening test, we used a paper-based IELTS academic listening test, which included 4 parts with increasing difficulty. The music intervention consisted of a 6-minute instrumental piece in calm tempo, selected based on tempo stability and prior research indicating its potential to reduce anxiety. To measure emotional arousal, we use electrodermal activity placed on participants' non-dominant hand. The data collection consisted of 3 main stages, lasting about 2 hours in total. In stage 1, participants signed a consent form, filled out the background questionnaire, and were attached the EDA sensors. In stage 2, they asked to complete parts 1 and 2 of the listening test, followed by the music intervention, and then parts 3 and 4 of the test. Lastly, in stage 3, a semi-structured interview was conducted to gather in-depth insights into participants' experiences and perceptions of the music condition. Here are the 3 EDA measures that we use to capture participants' emotional arousal during the L2 listening test. First, mean SCL, it's a tonic measure. And second, SCR event amplitude represents the peak intensity of short-term arousal spikes. And then third, SCR event frequency tracks how often these physiological spikes occur. Unlike the other 2 measures, we standardized this measure by calculating the number of SCR events per minute. This allowed us to maintain consistency across segments with different time lengths. For EDA data cleaning to ensure the data were comparable across individuals, given natural differences in skin properties, hydration, and stress reactivity, we standardized the first 2 measures using z-scores. This allowed for meaningful comparisons both within and between participants across test conditions and time segments. We also applied a low-pass filter to reduce noise and resample the data at 62.5 Hz, following best practices recommended by the acknowledged software developer. To analyze how anxiety changed over time, we segmented the EDA data into 3 analytical levels, enabling both broad and detailed interpretations of emotional arousal. At the macro level, we compared arousal before and after the intervention, and also across 3 overall phases: pre-intervention, music intervention, and post-intervention, to examine overall intervention effects. At the meso level, we treated each part of the IELTS listening test, parts 1 through 4, as a separate unit. Since the test increases in difficulty, this helped us trace task-level changes on how anxiety shifted as task demands intensified, and whether a short-term calming effect occurred immediately after the music, especially in part 3. At the micro level, we divided each part into 3 structural steps: pre-listening, where participants preview the questions; listening during the audio playback; and answering, where they wrote their responses by doing so, thus pinpointed precise moments of emotional fluctuation within each task. This resulted in 18 total segments, 7 pre-listening, 7 listening, and 4 answering steps. This 3-level segmentation was crucial to capturing the complexity of emotional arousal throughout the test. For data analysis, to examine how emotional arousal changed across the test, we used repeated measures ANOVA and t-tests on the EDA data. Now I will present the results of the macro level analysis. Let me start with the comparison between the pre and post-intervention phases. A paired samples t-test showed a statistically significant decrease in SCR event frequency after the music intervention. The event frequency dropped from 5.36 to 4.41. This difference was significant at p-value less than 0.001 with a large effect size. This suggests that participants had fewer moments of strong emotional activation after the music, supporting the idea that music helps regulate emotional reactivity. However, for the other 2 measures, mean SCL and SCR event amplitude, no significant differences were found between the pre- and post-intervention phases. That implies that while people may have reacted less often, their general baseline arousal and the intensity of those peaks didn't change much. To further examine changes across the 3 phases, we conducted a repeated measures ANOVA. All 3 EDA measures showed significant differences across phases. Mean SCL and SCR event amplitude were both lowest during the music phase, while SCR event frequency also decreased during music and remained lower after the intervention compared to before. Overall, this finding suggests that calming effect of music was strongest during active listening and weakened once the music stopped. Next is the meso-level analysis. Mean SCL differed across the 4 parts of the test with a large effect size. Part 2 had significantly higher mean SCL than Part 4. This suggests that arousal peaked midway through the test, possibly because of increased task demands or a gradual buildup of anxiety. For SCR event frequency, participants showed more frequent emotional reactions in Part 1 than in Part 3 and 4, and also more in Part 2 than Part 4, indicating stronger stress responses at the beginning of the test. After the music intervention, these responses generally decreased. Finally, SCR event amplitude also differed across test parts, although the post-hoc comparisons were not significant. Overall, the findings suggest that music reduced how often emotional spikes occurred rather than their intensity. Let's now turn to the micro-level analysis, which examined emotional arousal across the 3 task steps: pre-listening, listening, and answering. Today, as an example, I will only present the answering steps results. In answering steps, mean SCL was significantly higher in step 10 than in step 18. This supports the calming effect of the music intervention. SCR event frequency showed that step 5 had more responses than step 15, and step 10 had less responses than step 18. This reflects participants' reactivity fluctuated, which indicated a rebound of basic arousal in the later post-music stage, suggesting that participants re-engaged physiologically after an initial decline. For SCR event amplitude, step 10 had a significantly higher amplitude than step 18. This implies that while responses continued to occur later, their intensity weakened over time. Overall, emotional arousal during the L2 listening test appeared highly dynamic. EDA was sensitive to not only to the music intervention, but also to the structure and moment-to-moment demands of the test. The calming effect appeared strongest during the music phase itself, with mean SCL, SCR event amplitude, and SCR event frequency generally decreasing over time. At the same time, participants showed more frequent emotional reactions during the earlier parts of the test, especially parts 1 and 2. Interestingly, participants became less emotionally reactive during the answering period after the music intervention, although some fluctuations remained, possibly due to task difficulty. One important limitation of EDA is that it is not emotion specific. For example, increased EDA may reflect anxiety, but it may also indicate excitement, stress, or cognitive effort. Relatedly, EDA can capture the level of emotional arousal, such as whether activation is high or low, but it cannot distinguish emotional valence, that is, whether the emotion is positive or negative. Therefore, future research could combine EDA with neuroimaging techniques such as fMRI, fNIRS, or EEG to better examine the valence and neural dimensions of emotional experiences during L2 listening. This is the end of our presentation. Thank you for listening, and you're welcome to ask any questions.